Okay, so I'm going to make this video about chapter 9. It really is 9.1 and 9.2, the sections that we're going to cover. And I'm treating them as a whole. They're not like two different sections. What we're doing is a problem like the one that's here, like a sociologist conducts a study to determine whether there's a linear relationship between the family income and the percent of income donated to charities. The results of the survey given below, and the left is going to be the income in thousands of dollars, and the right side is donating percent as a percent of the salary. Then the question says, using alpha equals 0.05, is there enough evidence to assume there is a linear correlation between these variables? What is this alpha? Since we're jumping back all the way up to chapter 9, it's a little bit hard to explain what the alpha is. It's going to be a little bit more clear when we do after we cover chapter 6 and 7. But for now, just think about it like this is like a percent. It's the percent or the probability that that we would be making an error saying that variables are related when they really are not. Another way to say that is that we would be like 95% chance, 95% sure that the variables are related if something happens. So I'm not going to explain the material of this topic. I'm going to explain in this video how to obtain the correlation coefficient and how to obtain the linear regression line using the calculator, which is what I need you guys to do for the quiz and the exam next week. Okay, so let's find out. First of all, I want to do, part of this chapter is about putting these two data into a scatterplot and look at the scatterplot and see if these data look into a line, then they do fall. They are related. So what we need to do in a calculator is to put them, enter these data into our list. So for that, I'm gonna over here have this emulator for my calculator, and I'm gonna use T184 edition. That's I think the most common one. So I'm gonna press the stat button right here, and you get this menu, and number 1 says edit. So I can press number 1 and go to that, or press enter. So here I'm editing the list. I was fooling around with these numbers already, so they're here. If you have some trash in there, I'm going to scroll to the top to L2 and press clear and enter, and that will empty my list. That's important to do every time you work with a list, to empty the list and start over, because you have to be sure to have the correct entries. So I already have some data here. The 50, the 65, the 48, the 42 are the first 4 data points. The next one is 59, enter, and 72, enter. So I have 6 data points, right? 1, 2, 3, 4, 6. And then on the as the percentages, I have a 8 for the 50. I have a 6 for the 65. I have a 10. I didn't get it. 10 for the 48,000. I have a 9% for the 42,000. 5% for the 59,000, and a 3 for the 72,000. Okay, so once I have my 2 data on my list, they are stored already. So you don't need to do what I'm going to do next, but I'm going to show you that your calculator actually gives you a scatterplot if you want to see it. So I'm going to do, if you're in this screen that has the list, I can press the second function to the quit, and I'm back to my normal screen. Okay. So I can go up here, it says stat plot. So if I go second, this, my stat plot 1 is off. So I'm going to scroll down and say I want it on. Sorry, I'm here, so press enter. And I want it on. What type of plot I want? I want the first one. So scroll down. What type? I have these options. Right now, I am doing the scatter plot. Right. My list for my x variable is L1. My list for my y variables are L2. You saw that what that means is my lists are right here. I go to my stat button, and I did edit. My L1 had these variables. My L2 had the y variable. Okay. So okay, let me go back to stat plot. Now my last feature here, my stat plot said mark either a square or a little plus sign or a dot. I'll leave it like that. So now I'm going to look at the graph. So I'm going to go to graph. and it's empty. Because I did, although it is plotting these points, I'm not seeing them because there's like a 10 by 10 grid, and it's like 50x, 8 for y, so it's way over here, so I'm not seeing them. So what I need to do is scroll this manually, or I can go to the window button here, and you can see the window and move this all the way to, I don't know, 70 and something. But the easy thing to do is, instead of that, do a zoom button right here, and go to zoom. If I scroll down, 9 says zoom stat. So what this does is read the data in your list, and your stat list, statistics, and do the appropriate window. So this is the data. So you don't see the x and y axis, but you see this is in some scale, this is the data. Okay, so they are going to be correlated. There's a trend. Now we have the part this is using alpha equals 0.5. We're not going to say, it's not going to be enough for us to say, is there a trend? Is this going down as the income increases? Is it the 90% decreasing? What we're going to do is we're going to have a measurement of that, and this is what the alpha says. So, okay, so what is the best line? The line of best fit that goes through these points? Well, for that you go to stat button again, and I'm going to go to calculate. So right here, it's highlighted in the top, it's this one. If I scroll to the right, I can go to calculate. I can go to test. So right now I'm going to be in calculate, and sorry, calculations right there. And I want to do the linear regression, so number 4. So go back down to 4 and press enter. My X list again is L1, Y is still 2. You can change these, right? If you store, if for some reason you need to use L3 and L4, that's fine. I'm going to keep the frequency list empty. This is something that you might encounter later, but for now it's empty, right? Something cool is that this one says store the regression equation, and you can say, I'm going to do it. I'm going to store it in Y1. If you're familiar with the gram calculator, you know what Y1 is. If you're not, what I'm going to do is I'm going to do variables, Y variables, function Y1. This is very fast probably, but you can go back to the video and watch it again. It's very simple. So then I'm going to scroll down to calculate, press enter. Okay, so it returns the line y equals a plus b, where a is negative 0.21339 whatever x plus b, which is 18.78. So the cool thing is that I told the calculator to store this in my y1. So if I go here to my y button, in y1 I have that function already stored. Okay, I copied all the symbols for my ax, right, plus b. So it's right here. If you go again to the graph, now it plots the Scatterplot and the line of best fit. So this is the line. Again, we don't need to do this as part of our problems. It's just like a visualization of what's happening. Okay, this is the line of best fit. Now, the question here, A says, using alpha equals 0.5, is there enough evidence to assume is there a correlation? And part B says, if you answered yes to A, find the equation of the line. In fact, we already did part B. We found the equation of the line, and all we need to do is find what would it be if the income is 60,000, right? So that would be plugging 60 into X. Notice that it had to be 60, not 60,000, because this variable is already in thousands. Okay, so how do I answer A? Well, that's part that when I did stat and I did calculate linear regression, it did not give me that. So what I need to do, and nothing is wrong. Some of your calculators might have given you the R right here. Mine didn't. Nothing is wrong with the calculator if it didn't. What happens is there's something to turn on. There's a feature that is not on. So I need to go to the catalog down here. The second of 0 says catalog, so press second. Catalog. I'm looking for something called diagnostics. I never found a faster way to get this, so I'm scrolling down through all the functions of the calculator, and I need to make it to the D. So I press second catalog, and I'm scrolling down to diagnostics, and I want to have diagnostic on. Okay. Press enter twice, because the first time you're just going to select it, and you press it again, and it's done. Now you don't have to do this again unless your RAM gets resetted or something. I think in my emulator it's always going to be reset, but if you don't change your batteries, if you don't run out of power, it would be on forever. Now if I do it again, if I go to stat calculate, scroll down to number 4, press enter, scroll down to calculate, press enter, it returned me R. My R is negative 9.16, which is very close to 1. If you read the material, you need this R to be with absolute value close to 1. So this means it's close to negative 1, but it doesn't matter. As long as the number is close to 1 or negative 1, it's good. Now, how close? Well, that's what this table is for. I have 6 data points. For alpha 05, I'm looking at this number right here. Okay, I should probably zoom in. So I'm looking at this number. My alpha needs to be at least 0.811. It is because, as you saw, I got 0.916. It doesn't matter that it's negative again. You think of this, you want the positive version of this, you want the absolute value. So it's bigger than this. So the answer for part A is there is enough evidence to assume that the variables are linearly correlated. If my R would have been less than 811, then the answer is no, and you cannot answer the question B. Okay. So there's 2 tables. Sorry, there's one table with 2 variables here. One says for 2 columns, using alpha equals 05, you would use this column. Using alpha equals 01, you would use this column. Okay, and alpha will be given to you in each problem. Okay, so I hope that makes sense. Like again, what is the alpha? It's something like you're 95% sure that you're not assuming something wrong, that these data are strongly correlated. Okay, if you use alpha 01, you'll be saying you're 99% sure that the data are correlated. Okay, I hope I have time to do more examples before the exam. Bye.